Okay, we're at 6833 32nd Avenue Northeast in Seattle. Entering from a 3-inch clean out underneath the stairwell in the basement. Buzz up here on the 12th of February. Carrying the line. Okay, I have ABS pipe. Turn right there. Looks like a 90. There we go. This is cast iron pipe. And there's a transition from cast iron to 4-inch concrete pipe. Wow, first thing you see is a crack in the pipe right at the Y connection with heavily aggregate. So you're starting to see, you're past starting to see, and now you're really seeing the aggregate in the concrete, which means it's getting brittle. And as you can see right there on the upper right hand side of the screen, you can see a crack in the pipe where the water hits that wall and blowing it out. The pipe is now cracked. It looks like that crack is running right along the wall there. Buzz chopped out some roots there, but there's well-established roots, and it looks like a running crack on the left side of the pipe. The pipe's just been eaten away over years of usage. You can see that wear where the water runs down the pipe. It's aggregate, and the top of the pipe still looks fairly new. We've got some more roots coming through at a bill connection there. They've been chopped out, but after going through a 3-inch stack, you're not going to be able to get a full blade down there to chop all those roots out. So outside clean out would be very helpful. More roots coming through there at 39 feet. Almost 40 feet there. So I'm recording a video right now.
Oh, you are? Okay.
Got some commentary. You can see that this pipe is aggregate, concrete.
Oh, yeah, okay.
Concrete pipe. This is what the pipe looks like when it's brand new.
Okay.
You can see the heavy aggregate, which is basically the rock. So it's what makes up the concrete. The rock,
okay.
The mortar and rock.
Okay.
And in the very beginning, and I'll pull back and show you this. There's,
okay.
Right as it comes out of the house, it makes a turn,
uh-huh.
and it's blown out that turn, and it's starting to crack.
Oh,
which is,
great.
Yeah,
That's stupid. Why is there a turn?
Well, the way they construct it usually comes out of the house, and then it has to turn and go that way, right? So it comes out of the house at a 45-degree angle, and then it makes a turn. And you can't avoid turns, sometimes it's based on the layout, but
so it's starting to crack, right?
It's starting to crack. It's just worn out. The life expectancy on this pipe is 50 years. You said the house was built in what?
1950.
Yeah, so you've gotten.
We're close.
Yeah, you've gotten
we're
there.
done.
But it's it's obviously very aggregate, and you've got roots coming in at a few spots so far, and some running cracks, which is concerning because the cracks, once that cracks a little bit, now water's going to escape the pipe, roots are going to push towards it, they're going to bust right through that, it's going to make that pipe collapse. So it's still intact, the shape of the pipe. So there's a couple different options for you
Okay.
for a replacement, but we will keep cameraing down and go all the way out to the main, and then when I'm done with the video, we'll chat about some options. Okay?
All right. Thanks.
Yep. A piece of toilet paper hung up on that pipe, because as the pipe gets real aggregate and bumpy, solids will hang up on those aggregate parts, and also when there's offsets and roots in the line, it certainly doesn't help. The roots, toilet paper will get hung up on the roots and create a soft blockage. There's more roots coming out of the pipe there. Almost every bell connection. It's going to look like every 2 to 3 feet. Damaged pipe there right before the bell. The roots are really poking through, so they're well established on the outside of the pipe, and now finally finding their way in through cracks and breaks in the pipe. Another big root ball right there. Buzz was able to pop that through, but again, he can't get a full blade down there, so he's not going to be able to chop everything out with the access that we have right now. And now there's a transition to a 6-inch pipe, so we're just about the street level now, or at the property line. We've got roots coming in there too. They look like they've been cut out, but definitely coming in the bottom all the way around the top, so they're well established all the way around the pipe. And that puts pressure on the pipe and can cause it to belly as they spread the sections apart. You take 2 solid objects that are butted up against each other, and you push on either end, and it's either going to bow down or up. So you're going to start to see that with the pipe. Then it will hold water and deteriorate faster. Got a slight offset there, and that's what I was talking about. You start to see offsets because the roots that are coming through are spreading the pipe, and that's going to cause it to have to move somewhere else to make up for the spreading where the roots are coming in. Some more roots coming in there. Again, this is a 6-inch concrete pipe, and this is beyond the property line, heading up to the main. Hard to push. Now the pipe is starting to really dive, so that means it's really taking a turn down to connect with the main. You can tell that it's diving pretty good. There's aggregate pipe all the way around the whole circumference of the inside of the pipe, which means that the water is running down all of those areas. So it's wearing the top of the pipe out and the bottom. The little dust that you see floating through the pipe, those are sewer gases. Coming back up from the sewer, which is why you need a P-trap. And make sure that you have your sewer pipe well contained. And this pipe is looking quite rough. As you can see on the right side, there's some pitting that's going on, which is basically when the pipe starts to deteriorate, and you get areas where there's a little more aggregate and not enough inconsistencies in the concrete, basically. That start to wash away, and you have weak spots in the pipe. And right now we're in the street, so if this failed here, it would be a tough one to deal with, having to dig in the street. I would definitely recommend a liner and seal everything in place so we don't see any more degradation of the pipe, slipping and offsets, and possibly a separation or a collapse. Now here, if you look at the top of the screen, you can see the bell of the pipe of the next section. So one section's ending at the top of the screen there, and another one's beginning, and you can see the bell of the pipe, which means that it's slipped away and starting to fall away. That's a bad thing, because if that falls, then the earth falls into the pipe and it collapses it or clogs it up with dirt. And again, this is in the street, so it would be an expensive repair to dig. So So hopefully we can get a liner in here and seal the pipe in place and stop it from getting any worse. There's the main. This is where the city's responsibility ends, and this is where your responsibility begins, right at that seam, right there. There's a lip. Two pieces come together. This is where your side sewer begins and the city responsibility ends. So we'd have to line all the way out to this area in order to fully cover you. And that concludes our video.